we're gonna learn on how to evaluate super roots, which is the inverse of derivation. We already discussed it that super logarithms is like finding the superpower, or like the left exponent. So do you know that the square root? Do you know the square? So the square root is like finding the base of a number. So like square root of 64, it has a base 2. We already have the exponents, but we're finding the missing base. So what squared gives us 64? 8. 8 squared gives us 64. And then in the square root of 20, let's go do another example. Square root of 25 equals what? We're finding base. If it's a like root, we're finding a base. So we already know the exponent, which is 2. Then what about the base? It's 5. 5 squared is 25. Then what about the cube root? We're going to discuss super cube roots in this video. Cube root of 1000. Okay, so we already know the exponent, which is 3. Now, what cube gives us 1000? 10. It generates us 3 zeros. Okay, now logarithms is like finding the exponent. So like, let's go do like log base. I don't know for sure. Log base 5 or 25. So we have the base, right? We have the base, but we don't know the exponent. So 5 raised to the what power gives us 25. 5 squared is 25. And that's how we find an exponent. So we're gonna use super roots in this video, and super cube roots, and even super fourth roots if possible. Okay? So super roots are the inverse operation of derivation, but it's similar to super logarithms. So it should look like this, a square root, and then it should do like an S over here, a small S. Or there. Stands for super, I'm pretty sure. So let's go find the super root of 4. Now we already know it's 2 over here. We have a derivation of 2, but I want to find the base. So what derivated to 2 gives us 4? 2 derivated to 2 gives us 4. That's the answer. Then what about the super root of, let me say, 256. So we already know the derivation, which is 2, but we're finding the base. 4 derivated to 2 gives us 256. So the answer is 4. Now, super cube roots. It's the same, but it still works the same, but it's a derivation of 3, okay? So let's go say what is the super cube root of 16. We're finding the base. What derivative to 3 gives us 16? 2 derivative to 3 gives us 16. Then what about, I don't know, the super cube root of, hold on. So I don't know what to choose a number. So the super cube root of, hold on, I don't know. I'll probably pick, hold on, I just need to get back, okay? out my calculator. Let's see what is the answer to this. We know that 3 raised to 3 equals 3 cubed. So let me type that in the calculator. So it gives us, this is like an E notation. It's very similar to scientific notation, but instead of times 10 raised to something, we use E. Probably cube root this one. I don't know. So what's gonna do? I'm gonna type this in. Hold on. Probably 7.6255. I know this is such a big number. Here's the reveal of 3 raised to 3. I know it's so big. This is what a calculator gives me. I don't know what happened. That S should be in the wrong spot. I gotta put the S right here. I'm just checking if I get the numbers correct. Yep. I use E notation. It's kind of like scientific notation. So what 10 raised to 3 gives us this number. 3. 10 raised to 3 equals this very large number. I'm not including the S because I'm talking about this number, okay? Let's go try super fourth root. This is gonna be very huge, okay? The super fourth root of 65,536. We know that 2 raised to 4 gives us 65,536. So the answer is 2. What is the fourth root of the super fourth root of, hold on, I just need to do that again. 3. Okay, so it's gonna give us a large exponent, okay? So I'm just gonna make the root like this large. So let's go do 3 raised to the 7.62559748 E12, or times 10 raised to the 12. Okay, you might notice, you might not notice, but you might notice actually, because I know that 3 raised to 3 is 7.62559748 times 10 raised to the 12, right? And when I add like the base 3, I know that's integration right there. So 3 is the answer. 3 raised to 4 is this number. Even a scientific calculator couldn't calculate that. It's probably going to give you undefined, I'm pretty sure. Bye, guys. So when you're writing, what is the... I forgot to put the S over here. I forgot to put the S over there. But, yeah. Hold on, let me put the S over here. Okay? There. Now it's fixed. Okay? So the super fourth root of 3 raised to the 0.6255974 E12 equals 3. Yep, if you're wondering what is the super fifth root, it's the tetrahedration of 5, and the base is going to be found. Okay? If you're wondering, if it's the super sixth root, it's the same thing, but tetrahedration with 3. Bye, guys. I hope you enjoyed this video. Bye.